me and Christian were talking about beer, and I was trying to tell Maggie she shouldn't be drinking it because she's too young, because she was taking far too much interest in it, from what I could tell. Mia, do you think we'll have to watch Maggie in the future?
Yeah, maybe. I think she's good though, so I think we don't have to keep an eye on her.
We don't need to keep an eye on her. Okay.
Yeah.
That works for me. Right, let's get started, everyone. Well, we're going to do double integrals over a general region. Yesterday, we talked about how do you describe non-rectangular regions. You know, x goes from 0 to 3 and y goes from 0 to x plus 2. And we will be doing that, hopefully before the end of today, but certainly we'll be doing it tomorrow. So let's show you what a standard typical integral looks like. This is a version of question 1. And you can tell that it's a non-rectangular region when you look at the limits of integration. At least one of these guys will have a variable in. In this case, it's x. Now, when a double integral is written, what we call the outside integral, right? It's the last thing you do, must have 2 numbers in it. You cannot have a 1 to x or a y to x. That's impossible. That doesn't make sense in the world of double integrals, right? So you need numbers here and here, because this entire answer is going to be a number. But if you see any letter anywhere in these 2 places here, you're looking at a general region, non-rectangular, which means you can never separate them. So if you got a question that looked like this, and your temptation is say, oh yeah, separate it out as x's and y squares, right? You know how we did that when it was rectangular? Don't. It doesn't work. Even if you get an answer, it's still not the right answer. So just don't do it, right? It doesn't work. So that trick of separable variables has now left the building, right? You can't do it. So we just have to take them in the order that they've got. I prefer this notation. So when I do the questions from now on, I'll probably be putting these guys in, even though the original question just had 0x and 1, 9. So you do it in this order, that guy first, and then the answer from 1 to 9. So we're going to do from x equals 1 to x equals 9, this integral with respect to y, dx. Right, we know how to do these. That's not changing. With respect to y, 8x gets you 8yx. And with respect to y, negative 2y gets you y squared. And we'll evaluate that from y equals 0 to y equals x. Does that make sense? Are you comfortable with that? 8xy take away y squared. Now you can then plug in y the first time, so that becomes 8x squared, take away an x squared, minus a whole load of nothing, so I won't worry about that. And so we get that. And if you've done this thing correctly, if you've done your double integral the proper way, this bit here will always be x's, right? If there's a y left over, right? If somehow or other you've got a y somewhere, go back and fix it because you're just wrong, right? Now, if they switch the order, right? You did dx's, then you did dy's, then won't this be a whole load of y's dy, right? So these variables should always match up. Now, once you get to here, isn't that basically just a good old-fashioned calc 2, right? Just a normal calc 2 integral. So that would be add 1 to the power, divide by the new power, add 1 to the, oh, wait a minute. You should always be on the lookout for nice things. Isn't that 7x squared? Now I can do it. Add 1 to the power, divide by the new power, evaluated at 1 at 9, and I'm dot on that because that's just number crunching. And you got your answer. Let's try number 3, or a version of 3. We're going to do y equals 0 to y equals 1. We're going to do x equals 0 to x equals y. And the guy we're going to do is x e to the y cubed dx dy. So I'm going to do that guy first. If you integrate with respect to x, right? So bear in mind who the variable is, x. Doesn't this just count as a constant? So basically, isn't it a half x squared, that guy? So it's 1/2 x squared, that guy. Evaluated at x equals 0 to x equals y. Now, if you plug in and replace the x with y, this becomes 1/2 y squared e to the y cubed. And if you plug x equals 0, you get 0, so I'm not going to do anything. You now have that. And do you see everything is in y, so that's a good sign. So the first integral, you're going to have to take care of, integrating with respect to a variable, and you're probably going to have to, deal with some x's and y's all jumbled up. But once you've evaluated it, shouldn't you only be left with the other variable, right? Now, this is a Calc 2 question. How am I going to integrate this fella? Just tell me the method.
U sub.
U sub.
Agreed. And what's the U sub going to be?
Y to the third.
And you can finish that off, can't you? It's a Calc 2 question. I don't want to spend time doing Calc 2 questions when we could focus on, the harder part, which is the first step. Version question 4. S goes from 0 to 1. T goes from 0 to s to the power of 6. The function is the cosine of s to the power of 6. We're going to do t first and then integrate with respect to s second. So I'm going to do the inside one first. Okay. With respect to t, right, important here, with respect to t, what's the integral of this?
Wouldn't it just be t times that whole quantity?
Yes. Do you know sometimes your answer can be a lot easier than you think it's going to be? Would you agree that's, well, there isn't a t there, so I guess it's just that thing with a t stuck to it, which is what we have here. And now you're going to do t equals 0 to t equals, and I better check my answers, and I apologize, that's a 7. There. Here we go. So we have from s equals 0 to s equals 1. If you replace the t with s to the 6, and take away nothing, you're good. All right. What method would you use to integrate that thing?
U sub.
And who's your U sub going to be?
S to the 7.
And off you go, and it's done. Oh, I should have realized that one. This one was probably a better one to do than 4. I didn't notice it until later. It's going to be from v equals 0 to v equals 1. And it's going to be from w equals 0 to w equals e to the v. And the guy that we're going to deal with is that one. So obviously we're going to do that one first. With respect to w, what's the integral of the square root of 1 plus e to the v?
It's at a W.
Yeah.
Times it.
And then you're going to evaluate it. W0 to w equals that. If you replace that w with e to the v, you get e to the v, the ugly square root. Take away a whole load of nothings again. And we have that guy to integrate. What method should I use?
U
sub?
sub again.
Have you noticed that there's a lot of U subs happening on the second one and nothing too horrible the first time? Okay, what's the U sub you're going to use?
1 plus e to the v.
That actually comes out as, I think that comes out as the square root of u, so it's actually pretty easy to integrate. So if I gave you an integral that looked like these guys, do you feel comfortable about the process? So you always do inside one, outside one, everything should come out. And the second integral is probably going to be the one that takes you more time. And that's fine. Now let's generalize it just a little bit more. And this is a version of 6. And we're going to do a double integral over d. I guess R is for rectangle. Now they're using D. I mean, you could call that B, C, L, anything you like. It's just a thing. The function that we're going to integrate is that guy. And the region D is going to be described like this. Y is going to go from 0 to 7. And X is going to go from 0 to Y. So we've got a little bit of translation to do so that it looks more like this. But once we get it to look like this guy, it's going to be the same question. So I'm going to have 2 integrals. I'm going to have e to the negative y squared. I'm going to have a d somebody, right? And there are 2 choices, dx, dy, or dy, dx. But only one of those 2 actually makes sense and is the only one you should do because of that. So who goes first and who goes second? That's the decision.
Dx, then dy.
Right? So the x goes from 0, right, to y, so dx first, and then the y's go from 0 to 7. What was your thought process there? That's the right thing to do. What made you go that way?
Because you said you should always have 2 numbers in the outermost integral. And so y would be that one. And then x, since it goes from 0 to y, you want the y or the variable and a number in the first one or in the innermost one.
I like the way you said that. It's probably better than the way I was about to say it. Yeah. You know the number's going to go last. Once you do that, doesn't the rest follow? You know, there's only everything else has to follow from that point. Now that means you're going to be doing this guy, so I guess I should, figure that bit out. Let's see what we get. Again, you're going to just basically stick an x at the front, evaluated at 0, and then at y. And I'm getting a little bit tired of this book giving me only one question. And what the question is, what I'm getting at here is, isn't this just another darn U sub? I mean, wouldn't it be nice if just now and again they threw in an integration by parts, right? Just to, you know, mix things up a little bit, right? So I'm going to do a question that's like that and show you what it would look like. Everything else is the same, except a couple of little changes, nothing too major. Okay, now let's see what those changes do to the integral. Right, so not a lot of change there. Would you agree? Everything kind of goes the same places it went the last time. Just stick an X in the way you would expect to, and evaluate it at the two endpoints. Nothing really significantly different there either. There we go. Can you see that that question is not a U sub? Isn't that question an integration by parts? You see it? So just because maybe it's me and bad luck, you know, maybe I just keep missing the ones that are integration by parts, but there should be, and I hope there is, some situations where that is going to happen, right? Where you have to do an integration by parts. Of course, there are other things that could happen. Could it just be a power rule, which is very easy? And maybe you've got a trig one, you know, with a sine cubed in it, and you have to deal with that. The next question is the region D. And D is described as the region enclosed by the line y equals 6, y equals x, I should say, y equals 0, and x equals 3. And we're being asked to express this region D in what's called type 1, right? A region of type 1. And then in a region type 2. So far, so good. So, don't know what type 1 and type 2 is, but I'm going to show you in a minute. Right. I'm going to draw the line y equals x. I'm going to do the line x equals 3. Would you agree the line x equals 3 is a vertical line? I'm going to do the line y equals 0. And would you agree y equals 0 is basically the x-axis? So when you put those three together, isn't the region D that red shaded triangle? So far, so good. Right, now let's talk about this region 1, region 2 guy. Oh, hold on a second. Right, I forgot to tell you what question it was. Question 7. Right. Now, if I want to describe this region in terms of, you know, the range x goes from here to here and y goes from here to here, there are two ways to orientate it. The first one is vertical rectangles. Remember from yesterday? Vertical rectangles. Now, if I do this one, can I describe the region D in terms of x goes from 0 to 3 and y goes from the bottom value of y would be 0, and wouldn't the top value of y be x? Are you comfortable with that describes this region? X going from 0 to 3 and y going from 0 to here, right? And 0 to here is x, because y is equal to x. And that is what a type 1 is. A type 1, the numbers are on the X, right? X goes from number 0 to number 3. Type 1 has numbers where the X's go. So it doesn't take a lot to figure out. Isn't type 2 going to be the Y has the numbers? Now this picture is probably got too much in it, so I'm going to redraw it again up here. Okay, and this is the region that we're going to describe. And by the way, since this is 3, won't this guy over here be 3? Right? But I'm now going to do it going that way, right? By describing the region as a scanning of horizontal rectangles. Now, when you do it this way, won't the value of Y start scanning at 0 and finish at 3? Now, what about the X's? Right. X's go from here to here, agreed? Now, the biggest value that X takes is 3. What is the, that's this side here. What's this guy here going to be called? And remember, this line is called, yeah. This line is called Y equals X. Doesn't that mean X can be Y and Y can be X, right? They're interchangeable. So, boom. And that guy, oops, is type 2, right? Type 2, the numbers are in the range of Y's. Type 1, the numbers are in the range for the X's. Are we good so far? So when you are given a region, you can describe it by doing type 2 or type 1, right? Type 1 X's, type 2 Y's. Now you might say, well, why do I bother? A lot of the time it don't matter. The working is equally or horrible or equally nice, right? There's no great benefit computationally. But sometimes, just sometimes, it's better to do a type 1 or it's better to do a type 2. It kind of depends on what function you're integrating. Can you imagine a function that's really ugly in the X's, but really nice in the Y's? Can you imagine a situation where that might happen? That it's quite easy to integrate with X's and it's really horrible if you try and do it with the Y's. So in that case, wouldn't you want to do a type 1 or a type 2, depending on the situation? So there can be, sometimes anyway, a benefit to being able to do that. So this is question 8, very visual, so I'll just draw it. We have a quadratic whose equation is 3x take away x squared. And then we have a straight line. They have no imagination here, okay. Y equals x again. And the region D is that piece because they shaded it, right? That's the guy. And we are going to be given the function to integrate, right? So our function that we're going to integrate just happens to be that, but it can be anything you like. And we're going to try and write down what this double integral could look like in 2 different ways, or at least figure out which of the 2 different ways is the easiest to describe. So here goes. If I decide, I'll stick to green. If I decide to go vertical rectangles, right? Then I kind of need to know that point, and they tell me it's 2, right? Couldn't I describe the region D like this? X goes from 0 to 2, so I'm doing a type 1 here, right? Now, what would be the Y's? For this rectangle, what would be the Y's? And you have to do the Y's in terms of X or numbers. So what would be the bottom value for Y, which goes here? And then what would be the top value of Y, which goes here?
The bottom value would be x and the top value would be 3x minus x squared.
Does that make sense? Right. Okay. Now, if I tried, I guess I better draw it to show you it's impossible. If I tried to do, that's a type 1. Why is it a type 1? Because the numbers are for the x's. If I tried to do that same situation, that's this guy here, in the same straight line. If I tried to do it horizontally, it might look okay, but there's a problem. And it's a big problem that you can't cure. For starters, just for starters, if I was going to go this way, wouldn't I have to find out what this guy is and this guy is in terms of x's? Sorry, in terms of y's. So I'd have to be able to tell you what x is, right? Starting here, finishing here, what x would be going in. Now, I could probably figure it the y's. Second problem, aren't there going to be some horizontal rectangles that are only in the curve? See this one up here? Can you see you can't go scanning horizontally here? Don't you get places where you don't have one curve going to the other, right? Here it's straight line to curve. That's bad enough. But up here, isn't it curve to same curve? Type 2 is impossible. If I try to rewrite y equals 3x minus x squared, if I had to write that down as x equals some function of y, would you agree that you'd have a hard time doing it? So that's what killed that one. So you might get a region where the only way you can do it is, say, type 1, or the only way you can do it is type 2, in which case there's only one way to do it. That's how I'm going to set it up. So the x's are going to be going from 0 to 2, because numbers always go on the outside. And then the y's are going to go from x to 3x, take away x squared. And then the function, which is a pretty boring one, which is that guy, dy dx. So now I have set up the double integral. And I was given a picture to tell me what d was, and I created the limits of integration using that picture, doing a type 1, and that's where these came from. Put a little do it in order thing. We have a 0 to 2. This guy, with respect to y, I believe is 3y squared. You plug in 3x squared, you get 3 lots of 3x, take away x squared, take away 3 lots of x squared. And I'm going to stop here. That is doable. Would you also agree it's going to take you at least 5 minutes to do it? Because if I want to integrate this, won't I have to FOIL this out and collect like terms and then use the power rule? So it's not that it's hard to do, it's just ugly. And evidently, the answer is 56/5, because that's what it says here. Let's give you that same problem again, but this time I'm only going to do it up to the point where you decide, is it a type 1 or a type 2? So we have a guy here, 1, 1. We have the origin, and we have a guy here, coordinates 2, 0, right? And the region that we're interested in is this region here. Now, if I'm doing type 1, I'm going to do vertical rectangles. It's going to be type 1. If I do it type 2, it's going to be horizontal rectangles. Now, if you want the thing to work, don't you have to have like one curve and one curve, right? A start and a finish, right? Now, if I wanted to do this one, would you agree that horizontal is going to work better? Does that make sense? That in this shape, it's easier to go horizontal because won't the y values, what's that number there? That's 1. Won't the y values scan from 0 to 1? Now, what about the x values? Well, you've got to do a bit of work here. Don't I have to find the equation of this line and the equation of that line? And then rewrite them in the version x equals. So this one here is easy to do. It's y equals x, which is the small one. This guy here is going to be y equals, God in hammer, what will this be? It'll be negative x plus what? Negative x plus 2. Which means x is going to equal 2 minus y. Okay, are you happy about the equation of the line joining these 2 points as negative x plus 2, or do you want to see where I got that from?
Can I see where you got it from, please?
Sure. First thing I'm going to do is I'm going to find the slope of the line joining those 2 points together, right? And I'm just doing it visually. Would you agree it's a rise of 1 and a run of 1 and it's pointing downwards? So can you visualize that that was just a matter of eyeballing it and it's minus 1? Now, I'm going to pick a point that I know is on the line. I'm going to call that x1 and y1. And I'm going to use the point slope equation. And with a bit of luck, it's going to end up looking like that guy. So it's going to be y take away 1 equals negative 1 x take away 1. It's going to be y take away 1 is negative x add 1. That's y equals negative x add 2. So that's where I got this guy from. But because of the orientation here, don't I really want to know what x is in terms of y, not y is in terms of x? So I took this and I just rearranged it to go, add an x, take away a y, and we got that. So that there is a type 2, and that guy is going to be how we're going to express d. So d is going to go from y equals 0 to y equals 1. X is going to be from x equals y to x equals 2 minus y. And then whatever the function happens to be, and then you do a dx and a dy. That's essentially what the setup would look like. And then you just insert whatever function they tell you f of x, y is in there. So if they tell you it's x cubed y, that's what you put there. I think they tell you it's x plus y, so that's what you put there. Pause a minute. Are we good so far? That if you're given a region, you sometimes have to decide, is it easier to go horizontal or vertical? Is it going to be a type 1 or type 2? And sometimes both work. That's great. Just pick whatever one you feel like normally. Or in some cases, it really just makes sense to go that way. Now, you might think, well, why couldn't I go vertical? If you go vertical, aren't you going to change the line depending on where you're vertical? And you see, that doesn't really work well. Don't you want a single start and a single finish? Not, well, for this bit, that's the start and finish, but the minute you stop, it now changes into a different line, a different start and finish. So that's what would happen there. Let's try 10. We have a double integral over some region D. That's pretty basic. D is given to us, so that's nice. We don't need to worry about D. And it's going to be x goes from 0 to 6, and y is going to go from 0 to the square root of x. Okay, I can handle that. Since the x's are the numbers, they go on the outside. And since the y contains the variable, it goes on the inside. That function doesn't change. Y first, X second. Are you comfortable about how this became that? Right. 0 to 6 on the outside, 0 to square root of 6, square root of X on the inside. That doesn't change. If you're doing Y's, you do Y. If you're doing X's at the end, you do it in the end, right? Inside to out. Let's take it again through the first step. Okay. What is the integral of y over x squared plus 1 with respect to y?
Y squared over 2 quantity x squared plus 1.
What was it? What was the beginning of what you said? It sounded okay, Maggie, but I'm not sure 100%. What was it again?
Y squared divided by 2 quantity x squared plus 1.
You nailed it. It's exactly right. Now, if you plug in square root of x, you get, well, square root of x times itself, you get x. You get 2 over x squared plus 1 dx. Okay. Some people don't like numbers in the bottom of a fraction. Me personally, I don't like them either. Some people don't even like them on the top, right? Like a 3 up there and a 5 down there. They don't like them. But you can do this. As long as it's a number, you can pull it outside. Are you okay with that? You might not need it, but I've decided to do it. Do you recognize what method you are going to use to solve that integral?
You sub, of course.
Yes. Do you know I should have a rule for this book or this topic? And that is, when in doubt, look for a U sub. Does that seem to be a pretty good rule? And off you go and you finish it. Okay. Next question, I'm only going to take setting up the limits of integration. They tell us that D is enclosed by 2 curves. Well, 2, one's a straight line and a curve, but whatever. So I'm going to look at what y equals x squared would look like, and if I wasn't sure, I'd use Desmos. And if I did y equals 2x, it would look like this. So it's pretty sure, would you agree it's that little banana shape? That's D, right? That little banana shape. Agreed? I need to know some numbers here, so that is 0. You know, if you use Desmos, can you trust me that that's 2? Are we good? And if you want to know this guy over here, he is 4. Right, because 2 squared gets you 4 and 2 times 2 gets you 4. So that's pretty much all the numbers I want. So let's create D using type 1. And then we'll create D using type 2. Right, if you're doing type 1, you're doing vertical rectangles. And so the x's are going to be from 0 to 2. And won't the y's be from little guy, which is actually in this case the small side. Try that again. The small guy is x squared. And the big guy is 2x and y goes in the middle. After a few attempts, are you comfortable? 0 to 2, bottom guy, the curve, right? X squared, top guy, you go that way. Are you comfortable with that being type 1, right? Now, if you go horizontal, and I'm just going to try and pretend I know what I'm doing here, the guy that looks like this and, you know, the straight line goes like that. If you go horizontal, won't y go from 0 to 4? Now, that means you need to rewrite both these equations, right? The curve and the straight line, in terms of y. So y equals 2x now becomes x equals a half y. And instead of y equals x squared, won't x be the positive square root of y? So if we're looking at horizontal, isn't the curve the big guy and the straight line's the small guy? So the straight line goes here, the small guy, and the curve, which is the big guy, right? Furthest to the right is bigger, right? So the curve is big. The guy to the left is smaller, the straight line is small. Curve, big, straight line, small. That's what it looks like if you did a type 2. So far, so good? Now, the integral they give you is just x, y. Did they ask you to pick it? Oh, well, guess what? I'm not doing it, but they ask you to do it both ways. Can we pretend I did it this way and the answer is 42? What's the answer to that going to be? It's not a trick question.
$42.
It's going to be 42. So if you want to do them all the way through, go ahead. If you want to just say, look, I know if I've done the first one, the second one's the same, do ahead. I think that's probably busy work. So it's up to you if you want to do that or not. You know, if they say do it both ways, do it both ways if you want. If you want practice at just manipulating things differently. Otherwise, you could certainly just save yourself a bit of effort by not doing it that particular way. So what's the time like? Oh God, we get time for one more. Yes, we do. Which one shall I pick? I don't know. It's hard to choose. Okay, let's do this one. It's 14. We're doing the double integral over some region D of 5x cosine of y dA. D is described as bounded by y equals 0, y equals x squared, and x equals 3. So if I'm going to set up this integral, I really do need to figure out what does that look like. Well, y equals x squared looks like that. X equals 3 looks like that. Am I doing deja vu? Isn't that dead like one of the questions we did earlier today? Right, that's fine. So looking at the way this one is kind of set up, I'm going to go for a type 1. I'm going to do a vertical. And if you're going to do vertical, then the x's are going to be from 0 to 3. And the y's are going to go from 0 to x squared. Right, that wasn't too painful, agreed? So my integral is going to be from x equals 0 to x equals 3. And then I'm going to go from y equals 0 to y equals x squared. And then it's going to be 5x cosine of y. We're going to do a dy, and then we're going to do a dx. Are we comfortable so far about the setup? Now, could I have done that horizontally? Yes, in fact, if you look back earlier, didn't we do one like that? I kind of like those. Would you agree those look reasonably nice values to work with? So I would probably have picked that one anyway. So let's do these fellas. If you integrate the cosine or 5x, the cosine of y with respect to y, don't you just get 5x the sine of y? Right? Nothing too weird going on. Y equals 0 then to x squared. Right, if you plug in x squared instead of the y, take away nothing, you get that guy. Oh, I'm getting really annoyed with web design, but I have to ask it because it's part of my job. What method are you going to use to solve this integral?
U sub.
Was that a shock to you guys? Wasn't really a shock to me. I just keep my fingers. It can't just be me and bad luck. Would you agree? It can't just be bad luck, right? That we haven't found any question yet where you needed to do integration by parts, except for that one that I made deliberately to be that, right? There must be one that, you know, I should stop looking because then I'll just find it by accident. You know, I'll just do one at random. Ah, hey guys, we found one. But that's the guy you're going to get. And I'm going to say ... at that point, because can't you finish it off the usual way and you'll get some ridiculous answer. Oh, I should point this out in case some of you make your life harder than it is. It's okay to have cosine of 4 and sine of 3 and weird things like the square root of 7 in your answers, because we do not want decimals anywhere. So if the numbers come out weird, that's okay. That's the answer they're looking for. So don't think, oh, well, cosine of 9 is not an exact value. I better turn it into a decimal. No, don't do that. Just leave it alone. Every answer that we've got in this section is an exact value. So that's the exact answer. Last name and bye-bye. And I'll hang about for any questions. And Matthew will have a really good joke for me, I hope, by then.
Oh, I already said it in chat. Like at the
You
start
mean-
of class. Just because my camera wasn't working and I was trying to sort everything out.
Okay. Do you want to say it out loud? Or
Not
do you want-
really.
No, okay. I'm trying to find your joke.
That was pretty good.
Oh, it was it? Matthew, here we go. Well, I can either have my camera or my mouse.
That wasn't
that-
my joke.
You definitely need to know about that kind of alcohol dealing with us. Are you saying that you lot drive me to alcohol?
Maybe.
Maybe. Nah, I like you lot. Even you, Matthew. You take some getting used to, but I actually do like you. So you can get your 5% back.
All right.
Okay.
Also, I don't think I'm going to be here tomorrow because I'm visiting a different college.
Oh, that's
Again.
cool. Is that one of the ones you're interested in? I'm just being nosy now.
It's the one that I'm actually going to go to.
Oh, cool. Do they have some super duper computers?
I think they have they do have a good computer science program. That's why I'm going there. But like the main kicker is that like there's a bunch of art on the campus and it's really cool.
Oh, that's a good, interesting reason to pick the place.
Yeah, like it's cozy.
Yeah, you don't want to go to a place that looks like it's been in a war zone or a dump.
Yeah, and one of the other colleges I visited, it just looked like a bigger high school.
Yeah. Do you know what the ones I wouldn't want to go to? We still have it. Do you know, I call it the business building. You know that big, it looks like it's a prison. I don't know how else to, do you know that part of the, oh God, imagine going to a university that the buildings look like that.
I've gone to one that looked like a dentist's office.
I'm trying to imagine a dentist office, all clean and white and sterile.
I didn't go inside. Like it was just like an office building and like, the same
Big
kind of
square
office.
block with windows.
Yeah,
Yeah,
it was just kind of boring, and I was just like, where am I gonna live?
yeah. Well,
Uh,
you should go, if you like architecture, you should go to Scotland, because then you could go to my university with all these cloisters and medieval stuff. Wouldn't that be cool?
That would be cool if I felt like moving.
And then you'd have to learn Scottish, of course.
Yeah.
And see, I'm helping you because at least you're getting used to the accent.
Yep.
Okay. Any questions, guys?
Yeah, I have one real quick.
What you got? Dan?
Number 8 on 15-1.
Come
I
on up.
just seem to have made some mistake, I think, at the end.
Okay. I'm looking for it as we speak. 15. Oh, wait a minute. I better do the your version. That way I'm not putting in other numbers. Okay, here we go. Okay. You still have to fix question 1. You know that?
Yeah.
Okay, let's see what you got here. Ooh, I don't know where you got that. Okay, let's just do it then. Oh, it'll probably pop out as we go through the question. So we're going to do y first, then we're going to do x next. Right, with respect to y, x over y, its integral is x log y. With respect to y, this guy is just basically y over 4 or y over any number you like. So it's a power rule. So it's going to be 1 over 2x, and I guess that 1 becomes y squared. Did you get something that looks like that?
Yeah, I got y squared over 2x. Yep.
Okay, so that ain't where the problem happens. So let's just keep going till we get to the next step then. If you plug in 2, you get x log 2. If you plug in here, you get 2 squared, which is 4. 4 over 2 cancels down to get 2 over x. So that's the first time round. And then if you plug in y1, that's nothing because log of 1 is nothing. And you plug in 1 here, you get minus 1 over a 2x. Did you get that?
Yep, so far so good.
Okay, so this guy is just a number. So it's a power rule. So you're going to get 1/2 the log of 2x squared. This guy is just a 2 natural log of x. And this guy might catch you.
I got 1/2 times ln of x.
No, you didn't get caught. That's exactly what it
And
should
it's
be.
negative, yeah.
Okay. Now, I'm going to do a little bit of tidying up. It's not great. I don't expect it to have caused a problem, but these two are both the same, so you can add them together and get 3/2.
Oh, okay.
I don't think that should make a difference, but you know, maybe it will. We'll see. You plug in 4. You get 1/2 the natural log of 2 times 4 squared plus 3 over 2 the natural log of 4. That's the first bit. Take away, if you plug in 1, you get 1/2 natural log of 2 times 1 squared plus 3 over 2. I don't need that because that's 0, because log of 1 is 0. So you get that guy. Now, 4 squared can actually be written as 2 log 4. So I'm going to bring that out, and I'm going to call this the natural log of 2 times 4. No. Take that back. That's a normal number. It's not a log. So that's 8 log 2. Right. 16.5. 8 log 2. This guy is 3/2. And I'm going to call 4 2 squared, which is where my brain was thinking. Take away 1/2 log 2. And the reason I'm doing that is I'm trying to get everybody to be in terms of log 2. So that's this.
Oh, okay.
Now that becomes 2 log 2, which gets you 3 log 2. Take away 1/2 log 2, which gets me 10.5 log 2, which 21/2 log 2, and that's the answer.